morning, guys. Welcome to another class of auxiliary systems. Today we are going to finish with the theory, the concept about the bow thrusters. Yesterday you practiced installing bow thruster, windlass, hydraulic actuators, and you see that the mechanic is the same now. All of them are the relays, the switches, and the actuator, exactly the same, exactly the same. We are going to refresh quickly and finish with the installation of bow thrusters. And it's clear that I can install a bow thruster with a DC motor, reversible motor DC. That's number one. And also, I can use the same bow thruster with an AC motor, three-phase motor, activated with contactors and DC signal. And also, I can install the same bow thruster with AC motor, three-phase motor, with AC signal, AC hot. Oh, three-phase motor, AC signal, three-phase motor, DC signal in the joystick. Here I have AC, in the joystick here I have DC, in the joystick here I have DC. And also I can install a bow thruster with a hydraulic motor, no electric motor, no DC motor, no AC motor, hydraulic motor, like that one. And that motor receives the signal from the servo solenoid valve. And the solenoid receives the signal once again from the joystick with a DC signal. In other words, I have 4 different modes. In all of them, in the console, I see the same joystick. This joystick. This or this. Exactly the same. But you don't know if the motor is AC, if the motor is DC, if the motor is hydraulic. But the signal is the same. Pin, pin. Now, we are going to analyze one per one. Once again, the joystick is exactly the same. Oh, Mr. Lopez, but this joystick is too complicated. No, my friend. This joystick is exactly the same than this. This switch for left side, right side. You see 3 terminals. And this one 3 terminals. Where are the 3 terminals? I see a million of wires. Yesterday you discovered after.
Yeah, it was blue is the main.
Blue is the main, the common, the middle one. Blue is the middle one. And brown and orange are one side and the other side. No? Something like
brown and green. Yeah,
like
regardless, yeah.
Still,
and what about this and this? This is the power for the lights,
right,
and the computer that I have here. Oh, how I know that? You know, because you study electricity, advanced electricity and electronics. It's basically with what electrical or electronic tool you determine which one is which cable.
The DVOME, the voltmeter.
With the voltmeter and the continuity test.
Yeah.
That's it. That's it. Okay, I put power between the red and the black, and I have power here in the display. Okay, I have power. And now I need to identify which one is the common with continuity. You spend 5 minutes, 10 minutes checking that. All right. This is exactly the same. Oh, I have 4 terminals here. Okay, one power and power because I have light here. When I turn it on, I have light. This is the power, this diagonal, and the other diagonal is signal for one side and signal for the other side. This is exactly the same than this one, and it's exactly the same than this one. And all
continuity can be checked without power on that one, correct?
Without power. Check continuity without power. Always, always. That's clear, no?
Well, that one had particularly, we had to send power to get it to make the...
Yes, this one is supposed that when you activate ignition switch in the console, you have the lights on. In all of, not only the joystick, you have lights in the, you remember, on the gauge, when you did the panel, you remember? On all the gauge, the lights. In other words, this one, the red one, will be the purple from the ignition switch to activate power. And now, yeah, with power, I can use it, this one. Because without power, this one is not common. It's not in. You remember?
Yeah, so inside the board
Immediately
somewhere.
you have power here, this one become positive. You remember? Constantly, all the time. Because this is the common. Alright. But this is, I am talking about that because yesterday we discovered that. But this is not complicated. And you will to do exactly the same in other exercises, not only in bow thrusters. You remember, yesterday you have 3 different bow thrusters. At the end of the day, all of them are the same. No different. No, this one is, no, my friend, it's exactly the same. The other is exactly the same. And the other one, exactly the same. 3 different brands, exactly the same. This is why I don't like when my students say, Mr. Lopez, I want to be a Volvo technician. I don't want to know about the rest of the diesel engine. You finish diesel with me. It's different, the Volvo or the Caterpillar or the Cummins?
Not really.
Ah, okay, the push rod in this one, but the engine is the same, my friend.
Yeah.
The engine is the same. Blue smoke is blue smoke, no? White smoke is white smoke, doesn't matter if it's Cummins or Caterpillar. It's different, a Fisher Panda generator, no, all the generators are the same. Oh, this one used the technology of the inverter, it's the same. It's the same. If you are a doctor in generators, you are a doctor in generators. I want that you be a doctor in both. Okay, we are going to use any of those joysticks. Mr. Lopez, instead of the joystick, can I use a couple of push buttons? Yes. This one can be replaced for 2 push buttons. You remember? 2 push buttons like this. One here and one here. You connect the middle one, common, and this is signal 1 and the other is signal 2. It's exactly the same like this, exactly the same like this and this. You can use the switch that you prefer. Push button, toggle switch, or joystick. No difference. Okay. And all the solenoid control box are exactly the same. Power in the middle, power out. And signal here, positive for one side, signal here, positive for the other side, and both of them in the bottom, negatives. Some manufacture work opposite, interrupt the negative. You can interrupt the positive or the negative. You open or close the circuit to the positive side or to the negative side. Yes or no? Question? No? No question. Good. All right. We are going to refresh quickly this one. A bow thruster with a DC motor, reversible motor, of course, with DC signal. I have the bow thruster, my motor, reversible motor, my solenoid control box, the main power enter in the middle. Where is coming the main power? From the battery passing through the switch and passing through the battery switch, battery switch selection. Main power enter here, good power, no? Solid power, solid cable, solid terminal. And a good cable here for clockwise, and other good cable here for counterclock. And here 3 terminals. The middle for ground, signal, and signal. And those are coming from the joystick. The joystick receives power in the middle and send for one side and send for the other side. And bingo finito. This is the installation of the bow thruster. It's not complicated. It's not complicated. It's simple. Oh, the captain complained that the captain said, I have a movement in the starboard side but no port side. What is the troubleshooting?
You gotta check, well, you could start with checking the motor itself. bow thruster.
I explain you. With a big cable, with alligator terminal, bring power directly here. Yeah. Left side. Yeah. Right side. Okay, my motor is okay. It's not a problem with the motor. Number one, the most difficult. Now, I am going to do exactly the same with an alligator cable positive. Here. Here. Nothing. Solenoid control box out. I can replace the solenoid control box for a couple of relays. And bingo, finito. Yeah, finito. I solved it. Oh, the solenoid control box is good. When I power it here, when I power it here, probably it's the harness and probably it's the remote switch, the joystick or the toggle switch or the push button.
Or the wire going.
Or the wire.
Carrying, right?
Correct. Or the harness. Good? Alright. This is the traditional DC bow thruster. Okay, now we are going to talk about the same bow thruster with AC motor, three-phase motor. Where I found those bow thrusters?
Usually in big boats.
Mega yachts?
Yeah.
Mega yachts.
Cruise ships. that
Those
kind
bow
of stuff.
thruster work with AC motor. Oh, of course. In those boats, the generator should be running because I need AC power three-phase. No? That's okay? Oh, but those boats, they have 3 generators. They rotate the generator 8 hours each one. They are running with generators all the time. You are familiarized with that.
Those cruise ships are crazy. They have, like the MTU 4000s that
Yeah,
are
more.
around, they have like 6 of them
Yeah.
as generators.
Yeah.
It's insane. They're literally cities.
Always a generator is running. Always.
Crazy.
Always.
Yeah.
Always.
The engines are in the shop.
Okay.
MTU 4000s are
Alright, we are going to do the installation of a bow thruster with AC motor, three-phase motor, with a DC signal in the joystick or AC signal in the joystick. It's exactly the same, no different. The joystick is exactly the same. Oh, can I send between this and this a hotline? Yes. The joystick is the same. Good, papas? Alright. The motor is three-phase motor, and this is the configuration for that motor. High speed, low speed. I explain you in the motors how you configure high speed, high torque, low torque. Yeah, you remember the three-phase motor. Okay, bingo. And I have 2 contactors. If I have AC motors, reversible motors, I have pretty close to the motor a box, plastic box with a couple of contactors. Those contactors. You see? The contactor is a typical relay. Excuse me. The contactor is a typical breaker. 3 phases entering and 3 phases going out. That's the typical breaker. But this breaker can be activated remotely. Similar like a relay. With this signal in this particular case, this breaker, this contactor is activated remotely with an AC signal, AC. 120 volts, 110 volts, AC, 50 hertz, 60 hertz. When I powered this contactor, what happened? When I remove the power, we can connect and check this one. This one is with AC signal. This one is the same. This one is the same. Faces here, and here in the back, they have a signal 24 volts DC. With that signal, the breaker, that's clear? Contactor with DC signal, contactor with AC signal. Mr. Lopez, if I have 2 contactors together, one to activate up and other to activate down, how can I avoid that the people activate both of them at the same time? Because they have a plastic element here together between both of them to avoid that you activate both at the same time. The name of that link is the interlock. You order this breaker according with the capacity in amps and according with the signal that you want to activate, AC signal or DC signal.
the gauge of the wire is only because it's not being activated for such a long period of time.
Which one?
The signal wire.
This one?
Yeah. So it's just a small amount of
Yeah.
time, so
Yeah.
that's why it's allowed to be.
Yeah, it's a small signal for a short period of time.
Yeah. Because in comparison, I mean, you're running the same current through the bigger ones, but for a longer period of time.
Oh, no,
More
yeah.
amps.
Here you can pass 100 amps, 200
That's what I'm
amps.
saying, yeah.
But here is 5 amps or whatever.
Down
It's a small
somewhere.
signal. This one, now I am going to explain, is coming. This is neutral and this is hot. This is one of the hots. This is coming from one of the hots. But why this cable have less amps? You remember? You remember? What happens if I have a bus bar with a cable, heavy cable, 2 O's, 2 zeros,
Yeah, it drops.
100,
yeah.
200 amps, and enter in a bus bar. And from the bus bar, I have 3 cables, number 8. Okay. The 200 amps right now are divided in 3,
Yeah, it's like 60,
60 amps each one.
Yeah.
Yeah? That's exactly the situation. All right. Pay attention, guys. Those are the contactors. Contactor number 1, listen to me.
Just one.
Contactor number 2, pay attention for this configuration. I have my AC panel, the AC panel of my boat. Okay, if I have reversible motors, AC motors, it's because I have 3 phases in my boat. It's a big boat with big generators, 3-phase generators. And of course, if I have 3 phases, I have a panel with 3-phase breakers, double-phase breakers, and single-phase breakers. No? I am going to use the top breakers, 3-phase breakers, for those motors. The motor of the elevators, the motor of the windlass, the motor, 3-phase motors. The second group of breakers in the bottom, double phase, for dishwashers, for water heater, for water maker. No? The single phase breakers in the bottom of that big panel. Single phase breaker for outlets, for lights, for fans. Clear, guys? Alright. I am going to use one of those 3-phase breakers. That breaker said in the label bow thruster. Another breaker in the bottom is steam thruster. I'm going to use the top one, bow thruster. 3 phases, 1 phase, 2 phase, 3 phase. You follow me? Okay. Phase 1, enter in the first breaker in the first position. The second phase, the red one, in the second position. The third phase in the third position. And now I am going to feed the second breaker. The first one, the purple, in the first position. The second one, the red, in the third position. And the third one in the second position. I switch 2 in this breaker. The outputs are this with this, 1 with 1, 2 with 2, and 3 with 3. From the first one, I feed this, and this, because this is the configuration of that electric motor, 3-phase motor. However, if I use that breaker, if the contact of this breaker are closed, this motor rotates clockwise. If this one is off, contacts open, and I activate this one, closed contacts, the motor rotates counterclock. How I activate this or this is simple. This and this are with DC signal. The signal for that contactor is DC. I need a positive bus bar and I need a negative bus bar. Okay, from the positive bus bar, I activate my joystick or my switch or my push button. From one side, I activate this breaker. From the other side, I activate the second breaker. And bingo, finito. This is starboard side and this is port side. With AC motor, DC signal. Question about that one. This motor is 3-phase motor. AC 3-phase. This motor is DC motor. Reversible motor DC. Looks similar, but no, because the control box of this have the terminals for AC, and it's AC mode, 3-phase motor. Okay, perfect. I activate my 3-phase motor with a DC signal coming from the joystick. Now we are going to activate the same motor, three-phase motor, with AC signal. AC signal. Follow me, guys. The activation of this motor with AC signal, the activation of this motor with AC signal is practically the same. I have the same configuration from the breaker, phase 1, phase 2, phase 3. In the second one, I switch 2 with 3, and in the bottom, exactly the same connection, but the signal on the joystick in the middle is not a positive, it's a hot. It's coming from any of those phases, and a small wire, a small current, and I send one wire for up and other wire for down, and that's it. I activate, the top one is neutral and neutral because it's 120 or 110 AC.
When you wire those in, do you normally do that? Do you normally just split off a small wire off of one of the
Yes.
phases? Okay.
From one of
And
those
use it
phases,
as a
I
breaker?
connect the small wire. Like the small wire that we have yesterday in the red one, you remember?
Yeah.
There's no need for a fuse on that?
A separate breaker? Well, it's on its,
No.
it's on its own breaker.
No, separate breaker. It's nice, no? I can install here a fuse, 5 amps or something like this to protect the joystick. In that case, pay attention. I have this situation. I have a bow thruster with AC motor, three-phase motor, reversible motor. And the captain said, hey, my friend, I only have movement port side, no starboard side. What is the process for that troubleshooting? Once again, verify that the motor is working. How can you verify that?
You run power straight to it, so you could do one. It doesn't matter. You can take a phase.
Pay attention. My recommendation in that particular case. Okay, verify where is the contactor control box. That box, where the contactors are located. This one. Where is located that box? It's here. It's pretty close to the motor of the bow thruster. It's here. Let me open the box and I verify if the signal is AC or DC. The signal is AC. Let me check. In this contactor, 110. In the other contactor, 0. I don't have signal coming in the second contactor. Let me I connect in any outlet an extension cord with 2 cables. Let me check contactor number 1. Okay, good. Let me check contactor number 2. Okay, good. The contactors are good. It's the signal that is not coming. Let me check how is fitted the joystick or the push buttons or the toggle switch. Okay, I have power in the middle. And let me move it here. I have signal. Let me move it here. I don't have signal here. What happened?
Either
The joystick is damaged or the switch is damaged. I replace. You understand the process? I go to the control box. I identify the signal for the contactor is AC or is DC. Is AC, let me provide AC externally. Is DC, let me provide with a battery, 2 alligator cable. Nothing. Is this contactor is damaged. Bingo, finito.
for your
Yes or not? Now you are working with AC and DC. Now, because you are the doctor in the boat.
How are you checking continuity? Like, let's say that
Okay,
AC
to
out,
check
right?
continuity, you need remove power. No power.
Well, yeah, no, I mean for the distance, right? So like this motor, right, the AC motor for the, let's say it's for a bow thruster.
You see the signal between this point and this point?
Yeah, so if the joystick is, in the helm or wherever, and then you have the motors down, it's at the bow, in the boat. How are you checking continuity between the two? Are you using
I
like
love
wire
it.
tracer? Or?
I love it, the tracer.
Yeah, that's right.
The tracer. I put the generator tons in this end, and
Yep.
I go beep. Okay, my cable is good. Or with the time domain reflectometer.
Right.
This is the point where I love it, the time domain reflectometer, because that one says the cable is open 10 feet from here. That's good. This is the point where I love it to use the time domain reflectometer. That.
But in that case, it wouldn't matter. You have to pull the wire anyway.
Correct.
Sort of run a new wire.
You run a new wire.
Yeah, at least you have a reason.
You'll notice how the joystick is
Correct.
wire, it's way cheaper.
Correct.
Yeah.
Correct. In the middle of the ocean, probably you don't have time for this and this. Papa, pass a cable.
That's the problem.
Yeah. But don't forget, number one is provide power directly here with a source of power, a battery if it's DC, or a extension cord. No? With extension cord. New student, no? Okay. Papi, you don't have more questions here? This is a good explanation, my friend. It's clear now, because in the future you will find bow thruster with DC motor, bow thruster with AC motor. Oh, but this is AC motor, but the signal is DC. I don't understand that mixture. That signal is for the contactor to reverse the rotation in that motor. No? Clear? Clear this? What tools I need? Okay, my friend, you need a good multimeter, AC/DC. You need a test prop. No? And you need alligator cables, a lot of alligator cables. The test prop is nice. Because with the test prop, I love it. Let me explain something about that. When I connect my test prop, immediately I connect the test prop to the positive and the negative. I am able to provide, if I press up, I provide a positive. If I press down, I provide here a negative. Let me check. This is an AC motor, three-phase motor with DC signal. With DC signal. Okay, let me provide positive here directly. Positive DC. Pap! Pap! Okay. My contactors are okay. No? Because this is good. I don't need a battery with alligator. This is good. If it's AC, you need an extension cord with the cables open and introduce over there and verify that the contactor close. Good? How many times in the future you need to verify those type of AC motors, reversible motors? Of course, depend on in what type of boats you want to work. I want to work in a small boats, dinghy boat. Okay, probably you don't need to check those motors. All right. Now we are going to analyze the third type of bow thruster. Is the bow thruster hydraulic bow thruster with hydraulic motor. Now we are going to play again with the board with the hydraulic motor. But the hydraulic motor is working with a hydraulic fluid. Hydraulic fluid enter in one side, hydraulic fluid return in the other side, and the hydraulic motor rotate in both directions, depending if the fluid enter here clockwise or if the fluid enter here and return here counterclockwise. That depends on that. How can I change the flow of the fluid? With the solenoid control box, with the servo valves, with the body of valves. Yeah?
But you can have put solenoids.
Correct. Now I am going to explain that issue. Mr. Lopez, but in the console, in the flybridge, I have the same joystick. It's exactly the same.
AC or DC?
Exactly the same, AC or DC. Correct. Exactly the same. You go into the compartment where the bow thruster or windlass or what is installed, and you check the motor. Oh, it's hydraulic. I see the hydraulic lines. Let me follow the hydraulic lines because I want to find what? This is the motor, the hydraulic motor. I follow the line because I want to find the solenoid control box. Oh, this one is that one. And the solenoid control box, they have two lines connected to the motor and two lines going out through the source of power. The motor, the pump, and the reservoir. The motor, the pump, and the reservoir. Excuse me, now we are going to talk about that. In some cases, you have a central hydraulic unit where you have only one motor, AC or DC or diesel. You have one pump and one reservoir. And from that unit, you provide hydraulic fluid for this solenoid control box for bow thruster, other solenoid control box in the bottom for steam thruster, other solenoid control box for anchor, other solenoid control box for davit, other solenoid control box for pasarela, other solenoid control box for garage door, other 7, 8, 9, 10 solenoid with only one motor, only one container, and only one unit. This is the central hydraulic unit. Now we are going to talk about that. Okay, in this particular case, I identify which one is the solenoid control box related with my bow thruster. And that solenoid control box is operated for two solenoids, one in each side. And those solenoids receive the signal from my joystick. Joystick and joystick. Okay. Let me check that. It's DC because the solenoid said over there DC 12 volts, DC 24 volts. Let me bring a battery 12 volts and I provide power here. I provide power here. Nothing. That's solenoid. Let me open the solenoid. Let me check the power directly over there. Now if I provide power, it's the solenoid. Or it's the cable, or is this. You remember, I explained that in previous classes, no? Yes or not? Okay, this is the hydraulic unit. The captain said, I have bow thruster in port side, but no bow thruster in the starboard side. You go over there, disconnect both solenoids, and you provide power with a battery here. Right side, left side. Okay, my motor, everything is good. Probably the solenoid, or probably the harness, or probably the switch. How can I check the harness? With the time domain reflectometer or continuity, depending on the distance. How can I check this? How can I check this? I remove the power in the joystick. I identify which one is the common, which one is the output, and which one is the other output. And I check. Moving in starboard side, beep. Moving in port side, no beep. Replace that. Simple.
It might be off the topic a little bit, but your hybrid motor, it's DC, but it's also AC. So
Now we are
going reversible now, and a reverse.
I reverse over there because I have a contactors, because that's AC motor.
Yeah.
Nice, no? Guys, you are clear with this? I don't want to work in that boat because everything is hydraulic. I know hydraulic. Pay attention. The captain said that it's moving in left side, but it's not moving in right side. You check, everything is good. The solenoids are good, the cables are good, the joystick is good, the motor is good. What could be the problem in this particular case? Air in the system. Air in the system. Excuse me, Captain. Excuse me, Captain. I am going to release this feeding. Try again. Good. Now the other one, in the other direction. And you type. Oh, now it's moving in both directions. Air. Okay, what is, in that case, the next step? If you have air in the line, suddenly, it's because what?
You have a leak somewhere.
Because you have a leak of oil. You need to follow the lines with your fingers. Follow the lines. Oh, it's too much distance. Follow the lines. Oh, in this section between the salon and this, I don't have access to the cable. The cable is passing the pipe. Probably you have a leak over there, in that area.
Can you have pressure gauges for each line?
You can.
Just to say
But
something.
normally no. And those areas are difficult because you don't know where is the leak.
Yeah, at least you know there's a leak on one line. It just
You need to remove sealing.
Yeah.
No?
They had the large yacht that I was on with the captain. They had a hydraulic leak. Never found it while I was
Correct.
there. They had like 2 guys come in, they paid, they
Correct.
fixed it for a little bit, and then it would get air to the system again.
Correct. In that case,
Yeah.
in that case, once again, what is the solution?
On the line.
You have to,
A new line.
You're going to have to remove that
New
whole
line.
yeah.
Remove this line here, remove this line here, pass a new one externally, only to check. Oh, now it's perfect.
Is there a good way to pressure test that? Can you just unhook the line from both sides, cap one of the sides, and
Yes.
then throw a valve on
Yes.
it, and then just
Yes.
pressure test it
Yes.
with air?
You hear that? You pressurize the line in both ends, and you see if the gauge in the pressure tester stay constant.
And if it doesn't,
If
If the gauge goes down, what happened? You have a leak.
replace that line. Right.
That's what I was saying with the gauge and line anyway.
Later, I'm going to explain that process. It's not complicated. If you have a pump, vacuum pump, you can do that. The vacuum pump of the air condition. In air condition class, I'm going to explain that. I love work with hydraulics. If you are a good hydraulic technician, it's because you are a good electrician. Once again, the electrical part is the most important and fundamental of this. You remember yesterday, those hydraulic units. The connection of the feeding is 1 minute, but the electrical part is the most difficult. And yesterday in the laboratory we have everything here together. In the boat, no, my friend. In the boat, the joystick is over there. The servo valves over there. The actuator over there. And you need to go here, go here, go here. When you go over there, you forget. What is the red one? Okay, come back. Oh, it's the red one. Yeah, it's not easy. In a boat, it's not easy because yesterday we put together everything in the table, and it's easy make a jumper between this and this. But in the boat, probably you spend a lot of time. This is why, my friend, try to create a good team. Try to create a good partner from the beginning to work the rest of the life in your career. In my classes, not a star relation like yours, and for years, I found that my guys, 10 years later, 20 years later, hey, Mr. Lopez, you are together with Smith? Yes, Smith is my partner. From the beginning here in class. I hope you continue with this relation. And also keep the phone number of your friends, because you know that he is a good guy in parts, he's a good guy in outboard, he's a good guy, and in the future you say, oh, I need a part for a generator, let me call my friend Adrian, yeah, let me call my friend, yeah, because you need a good relation in this business. Okay, let me prepare. I want to show a couple of solenoids with a control box, and I want to explain the meaning of the central hydraulic unit. Good? Okay, guys. Now we are going to talk about the central hydraulic unit. How can I put together all the individual hydraulic systems in one central hydraulic unit? And I am going to explain the process to calculate the container, the reservoir, the motor, because this is the important part, and the pump. What is the capacity of the pump that I need to supply power for 7 systems or 10 systems, depending on the boat, with only 1 unit? That's okay? Everybody follow me? All right, good. For example, in this particular case, I have 4 different solenoid servo valves. One for a bow thruster, other for passarella, other for davit, other for garage door, no? Individuals. Of course, this one control this one. And I have another push buttons, a couple of push buttons to control this one. And I have another one with a other joystick, yeah? The control of this is for this, the control of this is for this, the control of this is for, yeah? Each individual servo valve have your own control. Is clear that? This control, this joystick is exclusive for this, because this is bow thruster. This is bow thruster. And this one push button is exclusive because this is anchor. That's okay? And I have a couple of switches here. And those switches are controlled with this one. No? Because this is, for example, passarella. The passarella. Yeah? Your individual controls in the console. Everybody follow me, guys? It's clear? All right. Oh, this is nice, Mr. Lopez, because I enter in the engine room and I see all of those organized. I'm going to post these videos in the afternoon, and you see the picture of other boat that I worked years ago. Good? All right. Now I am going to explain the process to calculate the capacity of the pump and how to select the appropriate pump. Question until that point? Okay. In order to be clear with that theory, I want to refresh quickly a couple of formulas that you need in the future to work. Okay, you have those formulas in your book. One topic, I will give you that additional paper for that book. This is the update of the new one. I will give you that. Okay, my friend, pay attention. Look at this. Concept that you need to calculate. How much horsepower I need in that motor. Or you can calculate the horsepower traditionally with the formula. You remember the formula to calculate horsepower some years ago?
Yeah, it's 52.
This is for torque. Torque is equal 52 times the horsepower divided by the RPMs. No? Okay. You remember when you calculate the total weight and divided by 500 and you calculate the horsepower? This is the ideal horsepower for that boat? Okay. This is the ideal horsepower. You can calculate now the hydraulic horsepower. Hydraulic horsepower is equal look at this. Hydraulic horsepower is equal to the pressure times the flow in gallons per hour divided by the constant 1714. 1714. This formula is very important. I'm going to print that paper and I'm going to give you this. how can I convert a mechanical horsepower into electrical horsepower? You remember that 1 horsepower is equivalent to 746 watts? That's very important. Okay, and the motor. Give me 1 second. Give me 1 second.
Pretty sure
Yeah, I remember.
that was from like that. That was in another year.
No, it was in this one. I just don't remember what chapter. I think it was an earlier chapter.
Okay, look at the formula. We need be familiarized with this. You remember in electricity we talk about the flow of electricity is amps. Okay, in hydraulic is the flow in gallons per hour, gallons per minute. Okay, it's the volume divided by the time. The volume of the fluid divided by the time. That's flow. The pressure is equal to force divided by the area. Okay, the horsepower of the fluid can be calculated. The pressure times the flow divided by 1714. This is the magic formula to calculate the horsepower of that fluid. The velocity of the fluid can be calculated is distance divided by time. Okay, the velocity is 0.32 times the gallons per hour, the flow, divided by the area of the pipe. With that formula, you calculate the velocity of the fluid. Pay attention to that formula. Velocity is equal that constant times the flow divided by the area. If the area increase, the velocity decrease. If the area decrease, the velocity increase. This is interesting, no? You remember in the house garden when you put your finger, you reduce the area, and what happened with the speed? You reduce the area, the speed goes up. You remove your finger, you increase the area, the speed decrease.
It was like when you're showing us the carburetor.
Same as a
the principle.
Yeah,
where they,
the Bernoulli principle.
and you showed it in slow. Oh, it was Rodriguez that showed it in slow motion, right?
oh yeah.
Yeah, he showed us a video of it in slow motion, and the area where pulls it up and high.
for
rest of the
carburetors.
air.
Yeah,
For
it's
the
in
carburetor,
carburetors
see it
when we explain the Bernoulli principle.
Yeah.
Okay, it's clear? The horsepower can be calculated with the pressure and the flow. The pressure and the flow. My friend, I know that the majority of you don't pay attention to this because you think that in the future you don't need. But when you are in the marina, in the middle of the ocean, working on that, and you don't understand nothing, you say, why I don't pay attention in that class? Why I never pay attention? Why I never read the book in that area? This is very, very important. I am explaining how to eliminate those 10 hydraulic systems and concentrate only in one. The most difficult part when you try to put all the hydraulic systems concentrated in one central hydraulic unit is calculate the motor, the capacity of the motor in kilowatts, and the capacity of the pump. To know the capacity of the pump, I need the output pressure that I need, and I need the flow. How much flow I need and how much pressure I need. When you order a pump, you call any manufacturer of pumps, the guy said, how much output pressure you require? I need 250 horsepower. 250 psi. And how much flow you need? I need 30 gallons per hour, 30 gallons per minute. They ask you two items, pressure and flow. With that pressure and flow, they say this pump is recommended, or this one, or this one. You understand? And now with the pump and the electric motor, you can design the container and you create the central hydraulic unit. And now with that electric motor and that electric pump, you are ready to supply power for those 10 units. Bow thruster, steam thruster, pasarela, tan. Doesn't matter that all of them are working at the same time because your pump and your electric motor and your reservoir is enough. You understand? It's exactly the same like when you size the inverter. You remember? Oh, I need an inverter to provide power for the entire AC panel. Oh, let me check how much is the consumption in this breaker, this breaker, this breaker. You added all of them. And after that you said, oh, I need 10 kilowatts. Okay, 10 kilowatts. Or 5 kilowatts or whatever.
Didn't you put an extra percentage on?
Yes, normally you added
20%.
no, 20%.
And for the lines, it's like gauging wire, right? You want to make
Correct.
sure your
You need the
pressure-
diameter of the pipes and the quality of the pipes. This is another topic that we are going to talk about. Today, there are excellent flexible hoses. For example, hydraulic supply. You visit hydraulic supply and you say, I need lines for a pump of 250 psi and 30 gallons per minute. What type of lines, flexible lines you recommend? And they say, I have this one. In rigid lines, what you recommend? Oh, it's for hydraulic fluid, or it's for diesel, or it's for water? No, it's for diesel. Okay, this type of copper pipes are excellent. It's for water, stainless steel. It's for, depending on the fluid, they recommend the line, the thickness of the wall, and the material of the fittings. All right, good. This is why one important thing that I need to keep clear is the horsepower. How much horsepower I need in that new system? Depend on the pressure and the flow. The velocity depends on the flow divided by the area. And okay, when you select the pump, you need provide to the fabricant of those pumps the output pressure, the output flow, and the head. What is the meaning of the head? How much distance can I reach with this fluid when I start the pump? How much is the maximum distance? Oh, it's 10 feet. Oh, I like it. Another pump with more head because my end equipment is located in the fly bridge and it's located from here 25 feet. And the head of this pump is only 10 feet. I need a more head. Okay, you need to provide the output head, the output flow, and the output pressure. And that's it. One way to convert PSI in head is this. PSI is equal to the distance, the vertical distance, divided by 2.31. 2.31. It's too simple, no? This pump, the output pressure is 60 psi. With 60 psi, how much distance I reach? Okay, the distance is equal to the psi times 2.31. It's 130 something feet. Yeah?
So 130 something,
Yeah,
138.
130 something. Nice, no? That formula is magic. Don't forget this formula. Pressure is equal distance divided by 2.31. And other magic formula is 1 horsepower is equivalent to 746 watts. Other magic formula is this. The horsepower of the fluid is equal to the pressure times the flow in gallons per hour, in gallons per minute, divided by this constant, 1714. What is the formula for torque? Torque is equal to horsepower times 5252 divided by engine RPMs. Those formulas should be impregnated here for the rest of the life. Okay, with that information, we are ready to calculate. I have a good example here. Look at this example. I need a pump with 20 gallons per minute, according with my calculus, and an output pressure of 250 psi. But I want to know how much is the capacity of the electric motor for that pump. Because I know the pump. I am going to explain how to calculate that. I need that pump. What motor I need for that pump? To move it, that pump, and work that pump with a 90% of efficiency. Okay, look at this. The horsepower that I need in my in my fluid is equal to the pressure times the flow divided by 1714. Pressure is 20, flow is 250, divided by the constant is 2.9 horsepower. Okay. You remember that I can convert mechanical horsepower into electrical. 1 horsepower is equivalent to 746 watts. Okay. According with that, 1 horsepower is 746. Then for 2.9 horsepower, I need 2.2 kilowatts. 2.2 kilowatts. Okay, I have the first number. I need a motor of a minimum 2.2. 2.5, 3 kilowatts will be nice for me because I added a little safety factor. No, 3 kilowatts. All right, good. And okay, what happens if the motor is double phase? It's better. Remember, if I select a motor single phase, I have too much consumption of amps. If I select a motor double phase, less. 3 phase, less. Okay, in this boat, it's a medium boat, I don't have 3 phase. I have only 2 phases. Okay, I'm going to select a motor 2 phase, 240, 60 hertz, because this boat is American. Okay, pay attention. Power, 2.2 kilowatts is equal to the voltage times intensity. The voltage is 240, I want to know the intensity. Okay, it's 2200 divided by 240 is 9.1 amps. I need 10 amps. Ah, okay, this is the consumption, this is the breaker, 10 amps. Nice, no? Okay, for a pump of 20 gallons, 250 psi, I need a motor, double phase, 2.2 kilowatts minimum, and I need a breaker with a capacity of 10 amps. Bingo, finito. Good? It's clear? All right, let me explain something. Let me show you something over there.
Do L's or bends in the fittings?
Yes.
Pressure?
Yes, you have a drag over there. Yeah,
So you usually don't want 90s.
correct.
You want you to keep them
But I'm
at
just thinking as far
45.
as,
This is why the recommendation is as short as possible, as straight as possible, the pipes, the lines. This is why the recommendation is the long distance in metallic pipes, straight pipes, and only the last portion in flexible lines. No? Okay, let's go one. I showed you.
Mine have actually been a lot.
Take care. To avoid the light. Thank you. No, here. Thank you. Okay, guys. This is an example of a central hydraulic unit. For example, in the previous exercise on the board, I mentioned 5 or 6 equipments, no? Suppose that I added those equipments are hydraulics. I check in each equipment how much is the flow required in each actuator, in each motor, and I added flows in gallons per minute, all of them, and pressure in each one, no? And at the end, I create a table. In the bottom, I have the total flow that I need is 20 gallons. And the total pressure is 450 psi. That's okay? This is the total flow, and this is the total pressure. With that pressure and that flow, and divided by the constant, I calculate the horsepower. With the horsepower, mechanical horsepower, I convert in electrical with the formula 1 horsepower equivalent to 746, and I calculate the motor. And now I have the motor and I have the pump. I need a pump of 3 gallons with a pressure of 250 psi. And I need an electric motor of a minimum 2.2 kilowatts. That's okay? This is why I select that motor 3 kilowatts. Double phase, 240. I have the motor, double phase 240, 3 kilowatts. I have the pump, 30 gallons, 250 psi. And now, and I have the reservoir. Okay, from the output of the pump, I create the supply manifold, the positive bus bar. From the return of the pump, I create the negative bus bar, the return manifold. And now I am ready to connect all the actuators, all the equipment that I wanted, because this motor and this pump is able to supply power for all of them working, running at the same time. Everybody follow me? It's clear, guys? Yes or not?
yes, sir.
I calculate the pump, I buy the pump, I calculate the motor, I order the motor, I calculate the breaker, I order the breaker, and the reservoir. And now I create my own central hydraulic unit. This is nice. And now my unit is running electrically, and I have connected all the elements that we are going to connect right now. Pay attention. This motor is AC motor. I am in the boat. This is to supply power for a lot of electrohydraulic equipment. This system depends of AC power. What is the meaning of that?
Alternating current.
This system depends that the generators
Two-phase,
are running. What happens if for some reason my generators not respond? I don't have generators. I am in the middle of the ocean.
They're using an inverter.
Right now I don't have anchor, I don't have windlass, I don't have nothing. That's good?
No.
Okay. This is why those central hydraulic units are created with redundancy, with backup. And the backup is mechanic. With a mechanic, of course, with a hydraulic pump powered with a motor. That pump is this. This pump is connected with this gear in one of the main engines. Or two pumps, one in each engine. Elio, can you hold it please for me? The name of this pump is the PTO. Where is located this PTO? Look at the shape of this pump. Where will be located that pump? This is a backup for this electrohydraulic system. Where will be located?
Bolted to the
On part of the drivetrain.
the gears of the.
Their cam or crank.
They're all connected anyway.
Yeah, doesn't matter.
You're famous, Elio.
But I've installed.
Say hi to Diego.
What's up, bro?
Okay, hola.
Sorry, Diego cut all that out.
I know.
Almost like a crank position. That was like changing transformation.
Shit. So it's on the
Look at the port.
yeah. No.
Goes right in.
In
there.
diesel, we learned that there's gears under there running from the.
Correct.
Right.
This is the starboard engine. I have one PTO or hydraulic pump, and I have another PTO in the other diesel engine. If my electric system fails for some reason, I have two backup electromechanic pumps. You like it? What is the name of that pump?
PTO.
PTO. PTO.
And if it's strictly hydraulic, then it would be a bigger unit if it's depending on the back end sometimes, right? Or in
some
between.
Yes, in some cases this is bolted in one of the generators, in the crankshaft of the generator or in the output shaft. Yeah, no
Yes,
problem.
sir.
You can connect this pump in one of the generators, in one of the main engines, but connect it with one engine for emergency. You have hydraulic system. Can you imagine if you don't have anchor? It's critical, no? You understand the dimension of this?
It's the same thing as having a emergency battery bank.
Correct.
And then switching over to that
You
emergency
switch for
battery
the other battery
Right.
bank.
You don't need your cranking batteries if you have a second set of cranking batteries.
pass it over.
Exactly.
It's all about
Exactly the
safety,
same.
redundancy.
You close the valves,
Right.
you close the valves or the traditional, and now you activate this valve. Now I have hydraulic from this. And I am going to work all of this weekend with this pump because the other system is damaged. No problem. You like it? That's the PTO. This is a typical PTO. And this is the pressure regulator of this pump. Good, guys?
Yes.
All right. Thanks.
Feel like that every morning. Oh,
When I gotta use the bathroom.
Diego.
Too bad they don't make marine grade.
Yeah, well, talk to his lawyer.
Just had a static control for like, so I get royalty on all
Okay.
the videos that we're in.
Sure you will.
I was already
This is
told.
the theory related with the central hydraulic unit and how can we connect those units. At the end of the class we can practice connecting this. Come on. Thank you.